So good morning to all of you. Let us quickly start what we discussed in the previous session. What is relation? Relation is a set of ordered pairs. If I say relation R is from set A to B, then relation R is set of ordered pairs A comma B such that element A belongs to set A and element B belongs to set B. And relation R is always subset of A cross B. This is what we discussed in the previous session. We already started discussion with respect to the properties of relationship. One of the property that we have discussed, that is reflexive. When we say the relation is reflexive, when the domain and codomain for that relation is the same set, means what? When the relation is from A to A, means where the domain and codomain is the same set. If all the elements for all the element x belonging to set A, if x comma x belongs to relation R, we say the relation is reflexive. So example, let us say your set A is this. These are the two relations. Relation R is given like this. Relation S is given like this. So you can see both R and S, both are reflexive because every element x belonging to A, means if I take this, all the elements. So if 2 comma 2, 4 comma 4, A comma A, B comma B, all these elements are belonging to the relation, whatever relations you are having, all the relations are reflexive. If any one of the element x belongs to A for which x comma x is not belonging to R, relation is not reflexive. So for that, I think we already had some discussion in the previous class, wherein I gave some exercise to identify whether the relationship is reflexive or not. So already we had some discussion with respect to reflexive property. Let us go ahead for today's session for some more property. Symmetric relation. When we say the relation is symmetric, a relation R on set A is symmetric for all x comma y belongs to A. It is need not be only the set A. You can have A to B relation. If you are having two sets, domain and codomain is also different, still no issue. Symmetric relationship, we can check out. How we can check out? If x comma y belongs to R, for all x comma y belongs to R, if y comma x also belongs to R, then we say the relation is symmetric. It doesn't matter whether the domain codomain are same or different. Our objective is what? For all x comma y belongs to R, if y comma x belongs to R, then we say the relation is symmetric. So if you can check this relation R, 1 comma 1 belongs to R. If we take x comma y belongs to R, then we need to check whether y comma x belongs to R. So 1 comma 1 belongs to R. If you interchange the position, we can see y 1 comma 1 also belongs to R, b comma b belongs to R, b comma b belongs to R. So this is a symmetric relation. Even this is a symmetric relation. Okay? Because the condition will get violated when you do have x comma y belongs to R, for you do have at least one x comma y belongs to R for which y comma x is not belonging to R, then you say relation is not symmetric. Otherwise the relation is symmetric. 2 comma b belongs to R, b comma 2 belongs to R, b comma 2 belongs to R, 2 comma b belongs to R, 1 comma 1 belongs to R, 1 comma b belongs to R. So all these relations are symmetric. Okay. S is not a symmetric relation on A. Now, why S is not a symmetric relation on A? Because 1 comma 2 belongs to S, but 2 comma 1 do not belongs to S. So therefore, this relation is not symmetric. Okay, let us come back to the example. So can you identify whether this R1 is symmetric or not? Can you tell me quickly whether this R1 is symmetric or not? Yes or no? Please respond in chat box quickly whether this relation R1 is symmetric or not. If any questions, please let me know first of all. Hope I am audible.
Sir, I have a doubt in the previous slide.
Yeah,
So in that
Sarah, tell me, what is the
relation
doubt?
was in that our relation was 1 comma 1 and b comma b. So how was that symmetric?
Hmm. See, our definition or property of relation to become symmetry is what for all x comma y. If x comma y belongs to R, sorry, if x comma y belongs to a relation R, then y comma x should belong to R. If this condition, if there is at least one x comma y belongs to R for which y comma x is not belonging to R, then we say the relation is not symmetric. When the condition is violating, when there is at least one x comma y belongs to R, or which y comma x is not in R, then we say relation is not symmetric. Otherwise, the relation is symmetric. So when you are asking about how this is symmetric, you think of this as a x comma y pair. X comma y belongs to R. So in this case, 1 comma 1. So for which do you have y comma x belongs to R? You just interchange. 1 comma 1 also belongs to R.
Yes, sir, understood now.
Okay. Now b comma b belongs to R. You think this as a x comma y belongs to R, for which y comma x is also belonging to R. So therefore it is symmetric. But if you look at the relation F, 1 comma 2 belongs to R, but 2 comma 1 do not belongs to R. You just interchange x comma, if x comma y belongs to R, then y comma x also belongs to R. This is the property of symmetric relation. Since 1 comma 2 belongs to yes, but 2 comma 1 do not belongs to yes, therefore this relation is not symmetric. Okay?
Yes, sir.
So Sarah, is it clear?
Yes, sir. Thank
Yeah.
you.
So now let me know quickly, what about relation R1? Is it symmetric or not? If it is not symmetric, then why it is not symmetric? You need to give one counter example. Yes, Hussein, you are saying no. Why it is no?
Sir, because 1 comma 2 belongs to R1, but 2 comma 1 doesn't belongs to that relation. And even 1 comma 9 and 1 comma 10.
Correct. So whenever you are giving justification, this perfect justification that you should give at least one counter example for which the relation or property is not holding. As you rightly stated, 1 comma 2 belongs to R, but 2 comma 1 do not belongs to R. Okay, correct. What about R2?
So symmetric.
Come on, quick.
Yes, sir.
Symmetric.
Yeah.
Yes, very good. And what about R3? You can just visualize here. What about R3?
So not symmetric.
Counter example.
So 2 comma 1 belongs to R, but 1 comma 2 is not there.
Correct. Very good. Perfect. So let us proceed ahead. So we already seen now what is reflexive relationship, what is symmetric relationship. Let's proceed ahead. What is anti-symmetric? When the relation is anti-symmetric. So a relation R on set A is anti-symmetric. This IFF means what? If and only if. The interpretation of this IFF is if and only if. For all x comma y belongs to set A, see, it doesn't matter whether your domain codomain is different. We don't bother about this. We bother about this property. If x comma y belongs to R and y comma x belongs to R, then x and y should be equal to y. Then and then only the relationship is anti-symmetric. Please try to understand again what is difference between symmetric and anti-symmetric. In symmetric relationship, if x comma y belongs to R, y comma x should also belongs to R. Okay. So there is no strict stringent condition that x and y should be same or should be different. Nothing like that. In general, if x comma y belongs to R, y comma x should also belongs to R. That's it. This is symmetric relationship. But a relationship is called anti-symmetric when x comma y belongs to R and y comma x also belongs to R. Then y and x both has to be same. If they are not same, if x comma y belongs to R and y comma x belongs to R and x and y both are not same, then the relationship is not anti-symmetric. So for example, let us take this relation R. 1 comma 1 belongs to R. This is x comma y. Okay, y comma x also belongs to R. That indicates x and y both are same. So this is holding for this. X comma y belongs to R. Y comma x belongs to R. That indicates x and y both are same. So this relation R is antisymmetric. If you take out relation S, so when the condition will violate, when x comma y belongs to R and y comma x belongs to R and x and y both are not same, then the condition is violating. If x comma y belongs to R and y comma x do not belongs to R, so we don't bother. By default, the relation is antisymmetric. Okay, but when it will not become antisymmetric, when x comma y belongs to R and y comma x belongs to R and x and y both are not same, then the condition is violating. So in this case, the condition is not violated. Why? Because x comma y belongs to R. There is no y comma x belongs to R. So we don't have to check whether this is same or not. So by default, this is antisymmetric. Similarly, going ahead, 2 comma b belongs to R. B comma 2 belongs to R, but B and 2 both are not same. So therefore, this relationship is not antisymmetric. This relationship is not antisymmetric. So is there any question? Please let me know. Is it clear or not?
So will you please explain
respond.
example second?
So can you explain?
For that, you need to again understand what is antisymmetric property. When this property will fail when x comma y belongs to R, for which there is y comma x belongs to R and x and y both are not same, then the relationship is not antisymmetric. Otherwise, the relationship is antisymmetric. Again and again, I am repeating. If x comma y belongs to R, and if you do have y comma x also belongs to R, in that case, x and y both has to be same. If they are not same, then the relationship is not antisymmetric. If x comma y belongs to R and you do not have y comma x belongs to R, doesn't matter. We just want to check when the condition is failing. When the condition is failing, when x comma y belongs to R and you do have y comma x belongs to R and x and y both are not same, in that case relationship is not antisymmetric. Otherwise, by default, relationship is antisymmetric. So let us take example S. 1 comma 2 belongs to R. Now when this will get violated, when you do have x comma y belongs to R, take it this example. X comma y belongs to R, you do have y comma x also belongs to R. As per the antisymmetric property, when x comma y belongs to R and y comma x belongs to R, both need to be same. But in this case, x and y, they are not same. Therefore, this is not antisymmetric. Now, considering this relation S, x comma y belongs to R, you do not have y comma x belongs to R. So, this property is not failing. Means what? X comma y belongs to R and y comma x belongs to R and x and y both are not same. This property is not violated. So, therefore, this relationship is antisymmetric. Relation S is antisymmetric because it is not violating the antisymmetric property. Is it clear or not? Let me know. Quickly give feedback whether it is clear or not.
Yes, sir.
Yeah, if any questions, please let me know. If no questions, let us come back to the example. Can you tell me now whether R1 is antisymmetric or not? Come on, quick. R1 is antisymmetric or not? You just need to check whether the antisymmetric property is getting violated or not. What is that property? If x comma y belongs to R and y comma x belongs to R, x and y both has to be same. If it is not same, it is not antisymmetric. So let me know whether R1 is antisymmetric or not. Come on, try quickly. There is nothing like you can answer. If there is a error, I will rectify. Don't worry. I'm waiting for the answer now, whether R1 is antisymmetric or not. Okay, one student is saying yes, Ritika is saying yes, Palak is saying yes. Okay, so Palak, can you justify why it is yes? Yes, your answer is right. Just justify why it is yes.
Sir, because x comma y belongs to the relation, then we don't have to check y comma x and whether they
It is
both are
not
equal.
set, it is element. It is not set, it is element y comma x. Y comma x is a element.
Yes, sir.
So what happens?
So the elements x
Yes.
comma y, it belongs to the relation.
Hmm. Hmm. You complete your
So we
statement. I
don't
am not
have
getting your
to
entire
check
line.
the further conditions, that is y comma x
Yeah. So
belongs
what do
to
you
r
mean
or
by
x equals to y.
okay? So perfectly right. Can you now, Palak, tell me what about R2? Is it anti-symmetric?
Yes, sir.
Is it symmetric?
Yes, sir.
Okay. So R2 is symmetric as well as anti-symmetric. Okay. R5. What about R5? Is it anti-symmetric?
Yes, sir.
Okay. So you do not have x comma y belongs to R and y comma x belongs to R, where you are checking x and y both are same. So yes, there are 10 comma 10, 9 comma 9, 2 comma 2, 1 comma 1. So both are having related to itself, not related to any other part. That's it. Let's proceed ahead. So this is third property. Fourth property now, transitivity. So relation R on set A is transitive if and only if x comma y belongs to R and y comma z belongs to R, and if x comma z is also belongs to R, or this is the condition, means if x comma y belongs to R and y comma z belongs to R, then you need to check whether x comma z belongs to R, yes or no. If for all x comma y and y comma z which belongs to R, x comma z is also belongs to R, we say the relationship is transitive. For example, you can check 1 comma 1 belongs to R, this is x comma y. Similarly, y comma z, 1 comma 1 belongs to R, so x comma z, 1 comma 1 belongs to R. So this is satisfying. B comma B, B comma B, so B comma B, satisfied. So this is a transitivity. Now 1 comma 2 belongs to yes, 2 comma B belongs to yes, 1 comma B also belongs to yes, so no problem. 2 comma B belongs to yes, so there is no B comma something. 1 comma B belongs to something, and there is no B comma something. So yes, this yes is transitive relation, because for all x comma y belongs to R and y comma z belongs to R, x comma z belongs to R. Now look at T. 2 comma B belongs to T, B comma 2 belongs to T, but 2 comma 2 do not belongs to T. So therefore, this relationship is not transitive. Is it clear or not? Is this property?
Sir, I
Please
have a
quickly,
doubt.
yeah,
How is R transitive? Because I did not understand.
okay, okay. Look at the definition again. Irrespective of this element, this is in general. For all x comma y belongs to R and y comma z belongs to R, if x comma z also belongs to R, then we say relation R is transitive. So how this is transitive? Look at this as a x comma y. So x comma y, x is 1 and y is 1. X comma y belongs to R. Now there is some y comma z. So consider this is y and this is z. Let me just use the pen. When you do have x, y, z, okay. So when you do have x comma y belongs to R, y comma z belongs to R. This is in general we are writing, no matter what is the value of x, y, z. And if it implies, or all these pairs x comma y, y comma z, if you do have x comma z also belongs to R, then we say the relation is transitive. So in this case, look at x comma y. We will treat this as x is 1, y is 1, and we will treat this as y is 1, z is 1. So 1 comma 1 belongs to R, 1 comma 1 belongs to R. So this 1 comma 1, that is x comma z, belongs to R. So this is holding. Similarly, considering this b as x, y as b, y as b, and z as b, so you can see b comma b belongs to R, b comma b belongs to R, and therefore b comma b belongs to R is also there, that is x comma z is also there. So nowhere this condition is violated. When the condition is violated, when you do have x comma y belongs to R, y comma z belongs to R, but x comma z do not belongs to R, then the condition is violated. So look at here. So this is your x, this is your y, this is your y, this is your z. So x comma y belongs to R, y comma z belongs to R, but x comma z, that is 2 comma 2, do not belongs to this relation T. So therefore this is not transitive. Is it clear or not?
Yes, sir.
Okay. So let us come back to the example and let me know whether R1 is transitive or not quickly.
No,
Why no?
it's because 1 comma 9 is not there in the set.
Means
So x 1 comma 2 belongs to R, and then y comma z belongs to R, but x comma z.
please try to understand when you are talking about x, y, z, whatever x belongs to y and the same y you are here now, y comma z, x to y, y to z. If you do have x comma y belongs to R and y comma z belongs to R, for which x comma z is not there in R, then you say the relationship is not transitive. So with respect to this, kindly explain again R1. Is the property failing? Come on quickly, respond quickly now. Is the property failing? I'm waiting to hear from you. Is the property failing or yes or no? Let me
Yes.
know.
Yes,
How
sir.
it is failing? How it is failing?
Because x
2
comma
comma 1
y.
doesn't belong to R1.
X comma y. What is your x comma y? Let us say x comma y is what here? In this case, you are talking about 1 comma 2. Okay. Now you tell me what is y comma z, so that 2 comma something is there. Is there any 2 comma something?
No, sir.
Then how you are saying the condition is violated? When the condition is violated, when you do have x comma y belongs to R, y comma z belongs to R, and x comma z is not there in R, then the condition is violated. Then the condition is true when x comma y belongs to R and y comma z belongs to R, x comma z also belongs to R, then we say the relationship is transitive. Otherwise, the relationship is not transitive. So, in this case, coming back to here, you can see here x comma y belongs to R, here it is T. Okay, x comma y belongs to T, y comma z belongs to T, but x comma z do not belongs to T. So therefore, this is not transitive. When the relationship is not transitive, when you do have at least one counter example, x comma y belongs to R and y comma z belongs to R, but x comma z do not belongs to R, the relationship is not transitive. Otherwise, the relationship is transitive. So you do not have this condition violation. 1 comma 2 belongs to R. You do not have 2 comma something. So there is no way the condition is violated. 1 comma 9 belongs to R. There is nothing like 9 comma something. So condition is not violated at all. 1 comma 10 belongs to R. 10 comma something is not there. So there is no question of condition violation. So therefore R1 is transitive because transitivity property is not violated. Now coming to the R2. Is it transitive? Yes or no?
Yes, sir.
Yes. Now coming towards this, what is this? R5. So is it transitive? Is this relation is transitive? R5. You can look at here
Sir,
the limit.
only 10 is
Yeah.
visible.
No, that's why I have highlighted here. Here. This is R5. Look at here, I am highlighting. Is it transitive? Come on, respond quickly, yes or no.
No, sir.
If it is no, then you should give counter example.
Sir, because there is an element 10, 9 and 9,
You
9.
say 10, 9 belongs to R.
It is.
So say, whenever you are giving answer, give precise answer. 10, 9 belongs to R. Okay. Then when you say it is not transitive, you are giving counter example. Yeah, come on, I am waiting for your answer.
No, sir, it is transitive.
Sure. Okay, which is it transitive? Viraj,
Yes, sir.
waiting to hear from you. Yeah, is it transitive?
Yes, sir. It is transitive.
How?
So because every
Hmm?
element in the set we can apply
Hmm.
the property like
Hmm.
one and one. We have and two
Okay,
and
okay. Viraj, forget about this example. Tell me when the relationship is not transitive. Yes,
not.
Viraj.
So
Yeah, when the
when
relation is not transitive.
we have like one and two and three, and we
No,
don't
no,
have
don't talk about anything one and two, something like that. Talk about X, Y, Z in general.
we have x and y belongs to R, y and z
X and
belongs to
Y, no, you don't say X and Y. You say
x
X comma
comma
Y.
y. X comma y
Hmm.
belongs to R, y comma z
Hmm.
belongs to R, but x
Hmm.
comma z does not belong to R. That makes it not transitive.
Correct. Okay. So look at here. Is there anything like something like that? 10 comma 1, 10 comma 2, okay, 10 comma 9. 10 comma 9 belongs to R. 9 comma 2 belongs to 9 comma 1 is there, so 10 comma 1 is there, so no problem. 10 comma 9, 9 comma 2, 10 comma 2 is there. 10 comma 9, 9 comma 9, 10 comma 9 is also there, so no issue. 10 comma 10, so 10 comma 10 and 10 comma 1, so no issue. 9 comma 2, 2 comma 1, 9 comma 1 is there, yes. So there is no way the condition is getting to be violated in this example, and therefore we say the relationship is transitive. All right. So coming back to, let us take this example, R3. So tell me now whether this relation is transitive or not. Is this relation is transitive or not? Come on, quickly. There should not be any time more here. It is just simply you are just checking whether the property is satisfying or not. So
No, sir.
whenever you say no, there has to be a counter example. So what is the counter example? So those who are saying no, why it is no?
So 1
10.
comma 1 belongs to R and
Hmm.
2 comma 2 belongs to R, but 1 comma 2 does not belong to R.
How you can correlate 1 comma 1 and 2 comma 2? Is the y portion is same here? See, in 1 comma 1, x is 1, y is 1. In 2 comma 2, y is 2. Is this you are having same thing? No, you cannot correlate this. When x comma y belongs to R, y comma z means something like this, 10 comma 5 and 5 comma something. So you cannot just correlate this here. No, no, no. This is not the valid justification for not saying this is not transitive. Always remember y is x comma y and same y is there in another, that is y comma z. If you do have x comma y belongs to R, y comma z belongs to R, for which
So,
x comma z is not belong to R.
so
Yeah,
9
tell me.
comma 9 belongs to R. 9
Hmm.
comma 3 belongs to R, but sorry, but yeah, no, sir, it is not.
Hmm. Hmm.
Sir, it is transitive.
It is transitive. Okay.
No, sir, it is not. So 10 comma 5
Why?
belongs to R,
But
10
5
comma
comma
2
Hmm.
10
belongs to R,
doesn't
but
belong to R.
Wait.
Sir,
10
but
comma
again,
5. Hmm. Hmm. Again repeat. 10 comma 5. Yes. Come on, continue. Yeah, continue. I am waiting to hear you. Hello.
so I guess it is transitive.
Hussein is saying no, it is not transitive. Hussein, can you justify?
Sir, as 10 comma 5 belongs to R, but 5 comma
10 comma
something
5 belongs
doesn't
to R.
belong to R,
Hmm.
R3. So
That
that's
doesn't
why
mean no, it is violating the condition. When the condition is violated, when x comma y belongs to R, y comma z belongs to R, for which x comma z is not there in R, then the condition is violated. If you do have x comma y belongs to R and there is no something y comma z belongs to R, nowhere it is violating the condition. When the condition is getting to be violated, when you do have x comma y as well as y comma z belongs to R, for which x comma z is not there in R, then the condition is violated. So is there any counter example which is proving that this is violating the condition?
no, sir, there is no counter example.
Yes, sir, it is
Okay,
transitive.
yes, it is transitive.
okay, okay. Mm, okay, so let's proceed ahead. We'll have some another. Okay, this is transitive relation. There is something called as transitive closure, reflexive closure, symmetric closure, transitive closure. I think it is not covered in this. Let me just take another slide. Let me check whether it is having in that. All right, what I will do now, we'll try to understand certain. What I will do now, I will have some exercise to be discussed with you. Just a moment. Yeah. Recall the relation below which is reflexive. R1 is a set of pairs A comma B where A is less than or equal to B. R2 is this where A comma B, it is collection of A comma B such that A comma B belongs to set N and A divided B belongs to set of positive integer. It's not positive integer, it is just Z, set of integers. Okay. And R3 is another relation. It is collection of A comma B such that A comma B belongs to natural sets and A minus B is equal to 2. So R1 is reflexive since for every A belongs to N, A is less than or equal to A, so it is reflexive. What about this? Is this R2 is reflexive, yes or no? A comma B belongs to N, set of natural sets, and A divided by B. This is the condition that A divided B belongs to set of integers. We do have all collection of A comma B such that A and B both are belonging to natural sets, and A divided by B belongs to set of integer. If it is satisfying that property, all these pairs are belonging to R2. So question is this, whether R2 is reflexive or not. We are talking about set N to set N. Therefore, we are talking about whether it is reflexive or not. R2 is reflexive since A divided by A is equal to 1. It is an integer. We do have A divided by some number belonging to set of integer. So at least there is some for all A means whatever possible combinations of A comma B you will take, you will definitely have one of the pair that is A comma A, which is also belonging to set of integer. Therefore, R2 is reflexive.
Sir, so
R3 is not yeah.
Even if one element of the set it follows that means if even one set is A comma A, then also we can say that the whole
Please try to understand. Please try to understand. This is a standard definition. It is another way of writing the set R3. It is collection of all the ordered pairs A comma B such that A and B belongs to set of natural numbers, and the property is A divided by B belongs to set of integer. Okay, so you can have all possible elements in this set such that which is satisfying this property. You may have certain pair like 10 comma 2, 10 comma 10, 10 comma 5, 10 comma 10, 100 comma 10, 20 comma 10. All possible combination of A comma B will be there. And we need to check whether the relation is reflexive or not. On the what basis we will check whether the relation is reflexive or not. When for all element A belongs to this set, if A comma A is also there, A comma A when it will be there, you need to check whether A divided by A belongs to this. If it is satisfying that property, A comma A satisfies the property, then we say yes, it is belonging to R2. If you do have all for all A comma A also belongs to R, we say relation is reflexive. So how we are checking? We are just checking A divided by A. What is the answer? A divided by A is 1, which is an integer. So no matter whatever A you are taking from the set, A divided by A is always 1, which is belonging to its head. Of course, it is not just A comma A, the pair that R2 is having. It is having all the pairs A comma B such that A divided by B is belonging to Z. Yeah, any questions? Please tell me now.
No, sir, I understood.
Yeah. Now coming back to the R3, it is a set of all ordered pairs A comma B such that A and B are belonging to set of natural number and A minus B is equal to 2. So we need to check whether this relation is reflexive or not. Relation is reflexive or not means what? We are just trying, at least we should have one counter example which will prove the property is not holding. When it is reflexive property, we are talking about element is related to itself. So when we do take A comma A, so that A minus A will become what? A minus A will become 0, which is not equal to 2. Therefore, this is not reflexive. Therefore, this is not reflexive. R3 is not reflexive since A minus A equal to 0. This property is not holding. For every A belongs to natural set N. So, symmetric we just checked, anti-symmetric. Yeah. In a symmetric relationship, A related to B implies B related to A. In anti-symmetric relation, when we do have A related to B as well as B related to A, it means A and B both are same. So anti-symmetric relation is not necessarily a reflexive relation. A relationship can be both symmetric as well as anti-symmetric, or it may not be symmetric, anti-symmetric, or it may have either one of the properties. So this is just a conclusion. Okay. Now let us check this example whether this relation is reflexive, symmetric, or antisymmetric. So this is a real set. Okay. So now what we need to check whether okay, first of all, what is this relation R? It is relation R is it is ordered pair x comma y belongs to R2. R2 means set of real numbers. You take a Cartesian product R cross R. Okay. So x square plus y square equals such that this x comma y, when they are belonging to this, they are holding this property, that is x square plus y square, that is equal to 1. So we need to check whether this is reflexive, symmetric, antisymmetric. So R is not reflexive since, for example, if you take 2 comma 2, 2 comma 2 belongs to R, okay? So 2 is also belonging to R and 2 is also belonging to R. 2 square plus 2 square, that is 4 plus 4, that is not equal to 1. So therefore, this is not reflexive. What about symmetry? R is symmetric because whatever x comma y belongs to R, if you take x square plus y square, that is equal to 1, its interpretation is this. Y square plus x square is also equal to 1. That interprets y is related to x. So for every x related to y is also related to x. Therefore, the relationship is symmetric. What about antisymmetric? R is not antisymmetric because there is one counter example. If you take 1 by 3 as x and root 8 by 3 as a y, which are belonging to R. Okay, so 1 comma 3, this is x, and root 8 by 3, this is y. This is belonging to R. Why? Because x square plus y square, that is equal to 1. And root 8 by 3 comma 1 by 3 is also belonging to R. But this x and y both are not same. Therefore, this is not antisymmetric. Now, transitivity, few minutes before we have checked. Let us, now I will not specify any hint or answer. You need to answer now whether this relation is transitive or not. What is this relation? It is a relation from x to y. With x and y both are belonging to set of real numbers. So what is this? When they will belongs to this relation, when this property is holding. What is this property? X is less than or equal to y. So tell me now whether this is holding the property.
Yes, sir.
Okay. Yes, it is transitive because x is related to y, and if y is related to z, that means if x is related to y means what? X is less than or equal to y is related to z means what? Y is less than or equal to z. When x is less than or equal to y and y is less than or equal to z, it automatically implies x is less than or equal to z. That means x is related to z. Therefore, it is transitive. Now, what about this? This is a relation having these elements. So tell me now, is it transitive? Yes or no? Is this relation is transitive or not?
Sir, no.
No, then counter example.
So, for example, if we have a comma a, the element belongs to R, and the element a comma b also belongs to R. No, it is reflexive. It is transitive. A comma b belongs to R. So it is transitive.
No, it is not transitive because B is related to A is related to B, but B is not related to B. So there is at least one counter example which proves it is not transitive. Now, it is a relation having all pair A comma B such that A is an ancestor of B. Tell me now, is it transitive? Yes or no?
Sir, I did not understand the previous.
You do have B comma A belongs to R. You do have A comma B belongs to R. This is X comma Y, this is Y comma Z. But you do not have B comma B belongs to R. X comma Z is not there. Is it clear or not?
But sir, we assume x comma z belongs to R. Na? Here, x is A and z is A. So then
Again
comma
repeated
a
here,
belongs
please refer here. Refer here. If x is related to y and y is related to z, then x should be also related to the z. Then and then only the relationship is transitive. X is related to y, that is this is x and this is y. Y is related to z. This is x, that is b, this is y, that is a. X is related to y is related to z. You do not have b comma b in this R. If it is there in R, then we say it is transitive. It is not there. B is related to A is related to B, but B is not related to B in this relation R. So therefore it is not transitive. What is the question now? Let me know.
Yes, sir, I understood.
Okay. Yes, Hussein, is it clear or not?
yes sir, yes sir.
Sir,
So
sir,
k
but we
comma
Yeah.
take
is
x
comma.
comma. Sir,
Wait. Let the Hussein talk. Yes. Yes,
I
Hussein.
assume a comma b as x comma y, then it should be related, transitive.
See, you need to check at least one instance which is failing the property. The property should hold for all the x comma y and y comma z belongs to R. If at least one x comma y and y comma z belongs to R, for which x comma z is not there in R, me what you are asking? Yes, Rini, tell me.
yes, I understood.
Okay. So yes, this relationship is transitive because A is ancestor of B, B is ancestor of C. Definitely A is ancestor of C. Now what about this? Is this relation is transitive? X and Y both are belonging to real set. Okay. X square is greater than or equal to Y. Is it transitive relation or not? No. One of the counter example, because 2 is related to 4, because 2 square is 4. 4 is greater than or equal to 4. This is absolutely right. You take 4 related to 10. Now what is 4 related to 10? That is 4 square, that is 16. 16 is greater than 10. But 2 is not related to 10. You do have x comma y belongs to R, y comma z belongs to R, but x comma z do not hold that property. That is 2 is related to 10. No, because 2 square is 4. 4 is not greater than or equal to 10. Therefore, this property is not, this relation is not holding the transitive property. Hope things are clear. Okay, let's proceed ahead. Irreflexive. There are some other terminologies. Irreflexive. When the relation is irreflexive, just like reflexive, we have checked for all element A belongs to set A. If A comma A belongs to R, then the relation is reflexive. When the relation is irreflexive, when all the elements belonging to A comma A is not there at all in the relation R, then the relation is irreflexive. Irreflexive. Okay. Please have a copy of this whenever I'm talking. At least a screenshot. All these properties. What about asymmetric? Asymmetric is what? When for all A comma B belongs to R, B comma A is not there in R, then we say the relation is asymmetric. So talking about symmetric is when A comma B belongs to R, for all A comma B belongs to R, B comma is there in R. Antisymmetric is when for all A comma B belongs to R, as well as B comma A belongs to R, A and B both has to be same. Then and then only the relation is antisymmetric. And third is what? Asymmetric. If A comma for all A comma B belongs to R, B comma A is not there at all in your R, then the relationship is asymmetric. Reflexive, for all A belongs to set
Sir,
A,
while
if A comma A
learning
belongs to R.
antisymmetric, sir,
Yeah.
while learning
Pardon, repeat.
antisymmetric, while learning antisymmetric, we had a relation in which it was the elements 1 comma 2. It had only one element. So that time we said that it is antisymmetric. X comma y belongs to relation, but y comma x does not belong to the relation. So it is not violating the property. So that's why it is antisymmetric.
See,
So
anti-symmetry will get violated when x comma y belongs to R. and y comma z belongs, y comma x belongs to R, and x and y both are not same, then the condition of antisymmetric is violated.
Yes, sir, but that time you said that even if y comma z does not belongs to R means
There is no question of y
not
comma z now.
violated.
Here it is, listen, there are no x, y, z. Here it is only x and y. In transitivity, we are having three elements, x, y, z. For the rest, it is only two elements we are talking, x and y. Yeah, Sarah, now ask what you are asking.
Yes, so that only for antisymmetric, the condition was that y comma x belongs to the relation, and x comma y belongs to the relation, y comma x belongs to the relation, and x should be equal to y. So when
Correct.
we were studying that, you said that if x comma y belongs to the relation and y comma x does not belong to the relation, so that time there is no point of the violation of the condition.
Violation,
So
correct.
the relation is antisymmetric. So
Correct.
if so it is asymmetric and antisymmetric both at that time, because then here also it is the same condition, no?
Here means what? What you are saying? You
For
are talking about
asymmetric.
asymmetric?
Yeah.
Yeah. So when the relation is asymmetric for all a comma b belongs to R, b comma a do not belongs to R, then the relation is asymmetric. Obviously, a relation R is asymmetric if and only if it is antisymmetric and it is irreflexive. Now, why irreflexive? Because if you do have when the relation is, see, this is just a lemma. When you will say it is asymmetric, when it is when a relation is asymmetric, then it is by default irreflexive as well as antisymmetric. You rightly pointed. Yes, obviously, x comma y belongs to R, but there is no question of y comma x belongs to R. For condition violation, y comma x is not at all there in R, so definitely it is antisymmetric. This is one thing, okay? So every asymmetric relation is antisymmetric also. But every antisymmetric relation does not give guarantee that it is asymmetric. Are you getting?
Yes, sir, understood.
Yeah. Looking to the time, we are not able to proceed. We will continue the discussion in tomorrow's session. Let me quickly summarize what we did in today's session. We have just learned about what are the possible properties of the set theory, what are the possible properties that we have in relation we are talking. The properties that we have discussed is basically reflexivity, irreflexivity, antisymmetric, symmetric, transitivity. In the next class, whenever we will discuss with respect to some of the closure property. If the relation is not reflexive, how to make it forcefully reflexive? If the relation is not symmetric, how to make it forcefully symmetric? If the relation is not transitive, how to make it forcefully transitive? So that closure properties are there, closure operations are there. So that we will discuss in tomorrow's session. So we'll stop here. Please your attendance in chat box, roll number followed by your name. Have a great day.